For question 1, we need to verify that the integral of y square x plus x square dx plus 4x minus 1 dy is equal to 99/4, where the vertical givens are 0, 0, 0, 3, and -3, 0 counterclockwise. First of all, we need to find out the region for this equation. So the region is this part, the shaded region. So first we will take this equation as z, y square x plus x square. Next we will integrate z respect to y, we will get 2yx. For this equation, we will take it as w. We will integrate w respect to x, we will get 4. Next, we will double integrate differentiate of w respect to x minus differentiate of z respect to y dA. Next is we're going to insert the lower limit and upper limit for this in a double integration, which is -3, 0, 0, 3 plus x, and insert the equation for differentiate w respect to x and differentiate z respect to y. dA is stand for dy dx. First, we need to integrate this equation by using this lower limit and upper limit. So we will get 2y square x over 2 minus 4y. Insert the value into this equation. Next, what we are going to do is we simplify this equation. Next step is we integrate this equation by using this lower limit and upper limit. And we will get x power of 4 over 4 plus 2x cubed plus 5 over 2 x squared minus 12x. Insert the value of this lower limit and upper limit into this equation. By using calculator to calculate this, we will get that this equation is equal to 99/4. Thus, question 1 is verified.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So my name is Mohamat and my metric number is 191936. I'm currently a third year student of Bachelor of Science, major in Statistics at UPM. So today I want to discuss a question in SL of MPH 3101, Advanced Calculus, question number 2. So this the question. Evaluate integral of yx squared dx minus y squared x dy, where c is x squared plus y squared equal to 2 squared, oriented counterclockwise. So from this question, we know that counterclockwise means that it is positively oriented. So Green theorem states that the integral of p dx plus q dy equal to double integral dq over dx minus dp over dy dx dy. So let's identify our p and q first. So from the question, we will get our pxy equal to yx squared and our qxy equal to negative y squared x. So we will integrate p with respect to y and we will get x squared. Where q we will integrate with respect to x and we will get negative y squared. So applying Green theorem where d is given by the interior of c. In example, d is the disk such that x squared plus y squared is less than 2 squared. So we will get integral of yx squared dx minus y squared x dy equal to double integral minus y squared minus x squared dA, where the disk of radius 2 center at the origin. So since d is a disk, the best way to do this integral is by using polar coordinates. So integral of yx squared dx minus y squared x dy, we will get double integral of negative y squared minus x squared dA. So we will factorize this equation first and we will get negative 1. We will bring negative 1 outside and we will get x squared plus y squared inside. So according to polar coordinate, we will get the x squared plus y squared, we will get r squared. So execute this integral and we will get the last answer is negative 16 pi over 3. So that's all from me. Thank you for listening.
Assalamualaikum and hi. My name is Aidil closely with metric number 1-0-1-3. So I will explain about question 3. Show that this equation is equals to 3, where C is formed by vertices 0, 0, and 0, 1, 2, oriented clockwise. So first of all, we have to plot the points of these vertices, which is 1, 0, 0, and 0, and 3. So 0, 0 happens to be here, 1, 0 happens to be here, and 1, 3 is over here. And then we get the equation of the line. For this one, it is y equals to 3x. This one is x equals to 1 and this one is y equals to 0. So then we will get these boundaries, which is x lies between 0 to 1 and y between 0 to 3x. So given this equation, we can transform it into this one. So anything in front of the x is the p, and anything in front of dy is the q. So we differentiate q and p with respect to x and y respectively. So differentiate q with respect to x, we get 2y, minus differentiate p with respect to y, we still get the same. And then the boundaries is 0 to 3x, since we want to integrate with respect to dy first. And for the x, it's 0 to 1. So then we solve the inside integrate first, and then we can cancel these two, so it becomes y squared. So we substitute this value into y. So 3x squared minus this one, and minus, we substitute 0 to y. So we get 0 minus this one. So minus plus will be 0. So we will be left with this one. And then we get 9x squared. We integrate this one with respect to x. And then we will get this one. And we get 3x cubed. And then we substitute this value into x. And then we get 3. So it is proven. Thank you.
And hi, my name is Namira Shafika binti Mohamat Nazri. My matrix number is 200449. So I will explain for question number 4. So the question need me to evaluate this. And this is the diagram given. So first I rearrange this function into this just to make it easier for me to understand. If you look at the diagram, it is like this. So I need to find for this one. So I use a slope formula to find this part, and I will get y equals to 3 minus x. After that, I need to find p and q. So I get this value from the initial function. P, I get it from dx, and q, I get it from dy. After that, we need to differentiate p respect to y, and we will get negative x. For q, we differentiate it respect to x, and we will get negative 9. After that, we need to substitute this value into this formula. So negative 9 minus negative x, and we will get negative 9 plus x. So for this one, I choose dy first and then dx. So where do we get this value? It's from this diagram. So if you look at this, negative 1, 3 minus x. So we look at, since we choose dy first, we look at a y which is negative 1, and for this one negative 1, and for this one is y equals to 3 minus x. So we put it into here. Same goes for dx. For dx, we look at this part which is negative 1, and we put it here, negative 1, and this one is 1, so we put it here. So we choose dy first because in this part there is an x in there. So just to make it easier, we choose dy first. We integrate dy first. And then just integrate it like usual. And at the end, we will get the final value is negative 218 over 3. That's all. Thank you.
Hi, my name is Nurwatika bin Qasim, and my matrix number is 200382. I will explain about question 5, which is use Green theorem to verify the area of a disk of radius alpha is alpha square pi. Radius alpha is defined by x square plus y square less than alpha square. The boundary of the disk is the circle of radius. In clockwise, the value of x is alpha cos t, and the value of y is alpha sin t. It is in the region of t from 0 to 2 pi. For the counterclockwise value, we will just differentiate the clockwise value, and we will get the x value is negative alpha sin t, and the y value is alpha cos t. So, by using Green theorem, area of a disk of radius alpha is equal to double integration dA equal to 1 over 2 integrate x dy minus y ds. So for the integral value, we will just use the value of t, which is from 0 to 2 pi. For the x and y value, we will use the clockwise value, and the dy and dx we will use the counterclockwise value. So by using that value, we will get 1/2 integrate 0 to 2 pi in bracket alpha cos t times alpha cos t minus alpha sin t times negative alpha sin t dt equal to 1/2 integrate 0 to 2 pi alpha square in bracket sin square t plus cos square t dt equal to alpha square over 2 integrate 0 to 2 pi dt equal to alpha square pi. This is the proof that area of a disk of radius alpha is alpha square pi.